something extraordinary has entered our solar system. It's moving faster than anything we've ever recorded, and scientists are left baffled. Traveling at more than 200,000 kilometers per hour, this mysterious object defies everything we know about comets or asteroids. Its path doesn't match predictions. Its speed is unmatched. And strangest of all, it may not just be reflecting light, it could be generating its own. A few researchers have even whispered a possibility that stretches the imagination. Could this be artificial? A probe, perhaps, sent by an alien civilization? If that's true, then the universe just became far stranger than we ever dared to imagine. The object has been named 3I, Atlas, seemingly ordinary, but carrying monumental weight. On July 1, 2025, astronomers first noticed it, a faint smudge drifting against a sea of stars. At first, it looked like just another comet wandering into our planetary neighborhood, one of countless icy travelers that occasionally pass near the Sun. But within weeks, that assumption was shattered. The discovery came through the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes in Hawaii and Chile designed to detect potential threats to Earth. These telescopes scan the skies for hazardous objects, our planet's early warning eyes in the dark. But ATLAS revealed something much more than danger. It revealed a mystery. The first clue was its orbit. Scientists calculated its orbital eccentricity, a measure of how stretched out an orbit is compared to a circle. For Earth, the number is tiny, just 0.016. Comets often have much higher values, but they remain bound to the Sun's gravity. ATLAS was different. Its eccentricity wasn't just above 1, it was far beyond. Meaning it isn't orbiting the Sun at all. It's an interstellar traveler, passing through from somewhere far beyond our solar system. To put that into perspective, before ATLAS we had seen only 2 confirmed interstellar objects, Oumuamua in 2017 and Borisov in 2019. Each was thought to be a once-in-a-generation discovery. Yet here we are, with a third. Clearly, these visitors are more common than we believed. But ATLAS is unusual, even among interstellar wanderers. It isn't just its origin, it's the speed. Over 200,000 kilometers per hour. That's fast enough to reach the Moon from Earth in under 2 hours. Tracking it is already difficult. Intercepting it? Nearly impossible. At first, astronomers classified it as a comet. Icy leftovers from the birth of star systems are expected to behave in predictable ways. But ATLAS doesn't. Its coma, the glowing halo of gas and dust, acts strangely, and early spectroscopy revealed compounds rarely seen in objects of this kind. And then came the question no one wanted to ask out loud: what if ATLAS is something else entirely? The designation 3I marks it as the third interstellar object ever confirmed. But unlike the others, its behavior doesn't fit established categories. Some astrophysicists suggest these objects are ejected debris from the chaotic birth of alien planetary systems, tossed out by gravitational slingshots to drift across the galaxy. If so, ATLAS could be a frozen time capsule, carrying chemistry billions of years old. But the evidence doesn't stop at romance, it presents anomalies that resist explanation. Comparisons to Oumuamua are inevitable. That object had a bizarre elongated shape and accelerated strangely as it left our solar system, leading some, including Harvard's Avi Loeb, to controversially suggest it might have been a probe or even a fragment of alien technology. Now, with ATLAS, whispers of that possibility have returned, louder than before. The biggest mystery is its brightness. Most objects in space shine by reflecting sunlight. Planets glow by scattering the sun's rays, while comets brighten as ice turns to vapor. But ATLAS's brightness doesn't match its estimated size. The Hubble Space Telescope detected sharp peaks and sudden fluctuations in its light curve, patterns more like an object glowing on its own rather than merely reflecting. If Atlas really is 20 kilometers across, comparable to Mount Everest, its light should be smooth and predictable. Instead, it flickers like something powered. And if it's self-luminous, that means it could be smaller, perhaps just a few hundred meters across, yet still glowing with incredible intensity. What could fuel such light? Natural explanations have been tested. Could jets of gas from sublimating ice reflect light in unusual ways? Possibly, but measurements from Chile and Hawaii show the outgassing isn't enough to explain its luminosity. Could it be internal radioactivity? Or heat stored deep inside? Neither fits the data. For an object to shine this way after millions of years adrift in interstellar space, something doesn't add up. That's where speculation takes a daring leap. Avi Loeb and Japanese astrophysicist Eric Koyama have suggested the glow could be artificial illumination. Imagine a spacecraft designed for interstellar travel, carrying lights for navigation, or even signaling. Unlike the light sail theory debated around Oumuamua, Atlas's glow appears steady, as if deliberate. The required energy is staggering, around 10 gigawatts, enough to power millions of homes continuously. If true, this is no accident. And Atlas's trajectory only deepens the intrigue. It's on a retrograde orbit, moving opposite to the planets. Retrograde paths are rare but not impossible. What makes Atlas extraordinary is that its orbital plane is tilted just 5 degrees from the ecliptic, the flat disk where most planets orbit. The chance of such an interstellar arrival lining up this closely is estimated at less than 1%. As Atlas passes through, its path takes it close to Mars, then near perihelion and later near Jupiter, alignments that look eerily similar to the gravitational assists we use to propel spacecraft like Voyager. Could Atlas be navigating, using planets for momentum? If so, intent might be at play. And if intent exists, then so does purpose. That is the most unsettling question of all. Why is it here? Could Atlas be a probe, silently mapping planets, scanning magnetic fields, or searching for signs of life? Could it be an ancient relic from a civilization long gone, still glowing with a power source beyond our comprehension? Skeptics, of course, urge caution. Rare alignments happen. Retrograde motion is odd, but not impossible. And unusual brightness doesn't prove technology. Most astronomers lean toward natural explanations, outgassing, dust, or statistical coincidence. Yet, when brightness, trajectory, and rarity all combine, the anomalies can't simply be dismissed. This debate isn't just scientific, it's human drama. On one side, researchers defend traditional models, cautious and careful. On the other, bold thinkers dare to ask whether we are witnessing technology from the stars. Patience against curiosity. Restraint against imagination. As Atlas approaches closer, the stakes grow. In October, it will pass near Mars at just 29 million kilometers, close enough for detailed observation. By the end of the month, it will reach perihelion, its closest point to the Sun, where solar heat could reveal its true nature. Weeks later, it will make its closest approach to Earth, not dangerous, but near enough for unprecedented study. With the James Webb Space Telescope, the Rubin Observatory, and countless amateur telescopes working together, scientists have more tools than ever to probe Atlas. What they find could go two ways. It might turn out to be a natural comet, carrying ancient material from another star. That alone would reshape our understanding of cosmic formation. But if the anomalies persist, too bright, too precise, too enigmatic, the possibility of something artificial grows harder to ignore. Atlas reminds us of a humbling truth. The universe is far stranger than we imagine. Every time humanity believes it understands the cosmos, a discovery arrives to shake that belief. Once we thought Earth was the center of everything. Once we believed our solar system was unique. Now we must confront the idea that interstellar visitors, whether natural or technological, may pass by more often than we realize. In the coming weeks, every observation will matter. Every photon of light, every spectral reading, every calculation brings us closer to an answer. Atlas is not just another object. It is a challenge to science, to philosophy, and to our sense of place in the cosmos. So what should we do? Watch closely. Question deeply. Keep an open mind. Because Atlas is only one of countless travelers in the galaxy. Others may be out there, waiting for us to notice. This is a story unfolding in real time. And the truth about Atlas, whether comet, relic, or probe, could change how humanity sees the universe forever.